Welcome all to my channel. In this video class, we see about how to draw a parabola under the eccentricity method. Maximum procedure for this is almost similar to ellipse drawing by eccentricity method. Refer the rules and other details for eccentricity related terms in my previous E.G. video class 5. Now, let me read the problem given in this drawing sheet. Construct a parabola when the distance between focus and directrix is given as 80 mm. Draw a tangent and normal at any point on the parabola. Here the main dimension is given as distance between focus and directrix as 80 mm. That is the only data given. Using this we have to draw the parabola. Here first refer to the final finished drawing for easy understanding. However, we see the procedure of drawing by step to be easier from the next one. As per the problem, here the distance from the directrix for the focus is given in the problem, that is 80 mm, and this may be suitable to eccentricity method. One of the important instruction to note here is first see the space arrangement to draw the parabola with the given dimension, where to draw the directrix, etc. If not planned in advance, not only for this problem, for other problems also, then there may be insufficient space for finding more points or the last one or two points for the parabola, or other drawings also may affect because of this. So it is to be planned in advance. Then in that case it may be necessary to redraw by wasting that time. That is the reason why in advance planning for space is very important. As per step 1, now first draw the directrix line vertically on left hand side of the drawing sheet as shown to an approximate height and name it as directrix. Mark it as A dash. Draw a horizontal line from the directrix and perpendicular to directrix. That also should be remembered as shown, and mark it as B dash. Next, as per step 2, locating the focus and vertex are the steps. For this, the distance from directrix to focus or vice versa is given as 80 mm in the problem. So mark it on the line BB dash and name it as focus F, that is 80 mm from B to F. Since it is given in the problem to draw the parabola, we know already for parabola the standard rule is eccentricity E equal to 1 or vice versa. That is, if E is equal to 1, then it is a parabola. Now, to be E is equal to 1, take a midpoint between B and F as V, that is vertex, so that E is equal to VF by VB, that is equal to 1 by 1, that is equal to 1. that is actually the ratio 1 plus 1 equal to 2 parts, which is given as 80 millimeter, so that 1 part equal to 40 millimeter. That is why it is being a midpoint between B and F as vertex V. Now, as per step 3, draw vertical line or perpendicular line at vertex V as shown, and this is also parallel to directrix. Then take the distance VB in the compass and mark on the vertical line from V, so that VB equal to VC as shown. Then extend the line after joining B and C based on the required length approximately. Then as per step 4, draw parallel lines and mark them. That is, draw parallel lines to VC. This is also perpendicular to the major axis. For this, it may be drawn required approximate number of parallel lines and at the approximate equal gap. The gap may also vary depending upon the requirement. It only going to decide the path of the parabola as shown. It may be numbered as 1 dash, 2 dash, 3 dash, etc. in the BC extension line, and may be numbered as 1, 2, 3, 4, etc. That is the joining points of the perpendicular line with the main axis line in the BB dash. Then as per step 5, draw line from directrix and mark them as 1 double dash, 2 double dash, etc. That is, extend the line CV vertically below the main axis line BB dash, so that CV is equal to VC dash. Same height may be taken here. By joining the point B to C dash, it may be extended, which will give the joining points as 1 double dash, 2 double dash, 3 double dash. This is only additional step, because from the main axis above and below same distance is required for finding the parabolic path. If we take or mark the points at these places by arc, same arc may be used here also from the center line. So this line is only additional. Either this line or this line, any one is sufficient. But additionally we have to show this line for guidance of the parabola. Next, as per step 6, mark parabola path arcs J1 and K1. That is, the parabola path finding points to be marked. For this, first take 1 dash distance in the compass and mark the arcs from focus F on the 1 dash line, 1 arc, and 1 double dash line, another arc on the vertical line, and mark them as J1 and K1. Similarly, then take 2 dash distance in the compass and mark the arcs from same focus F on the line 2 dash, 1 arc, 2 double dash, another arc, so that mark them as J2, K2 in the vertical line as shown. Similarly, as per step 8, complete all other arcs for the parabola, that is J3 point, J4 point through the arc, J5 point through the arc, J6 point through the arc. Likewise here, K3 point, K4 point, K5 find, K6 point through the arc should be done focusing or arc starting from F and mark all these arcs similar to the previous steps. Now we know almost required number of points for drawing the parabola. Next, as per step 9, you have to join all the points for the parabola. For that, starting from V as shown here, V to J1, J2, J3, J4, J5, J6. Then V to K1, K2, K3, K4, K5 and K6. Like that, the required parabola curve is drawn. This may be done with freehand joining, but it should be smooth and neatness in appearance. Then we have to do the step 9, that is tangent and normal. Now as per step 10, to draw the tangent and normal, mark a point P on the parabola at a suitable place as shown. Any place on the curve may be decided for choosing the P. Now join the point P and F, that is F is already known. Then draw a line perpendicular to PF from F so that it meets the directrix at the point G. Now join the line GP, P is already known, G is known, so join the line GP and extend. This is the required tangent to the parabola. Name it as R dash as shown. Then draw a perpendicular line at P to RR dash, and this is the required normal, that is perpendicular to the parabola at that point P. Name it as S dash as shown here. Next, regarding the pencil grade usage etc., first mention the dimensions. If more dimensions, we may mention it in the drawing itself. Since only one dimension is given, that may be noted here like this. Then with respect to tangent and normal, after drawing it should be mentioned here like this to indicate tangent and normal. Then with respect to pencil usage, as shown here, the parabola main curve should be in dark lines and used with HB pencil, and as well as the tangent and normal should be dark in nature with HB pencil. Use 2H pencil for thin lines, that is for other supporting lines 2H pencil may be used. Directrix and as well as the axis line may be used with medium dark using HB or 2H. With this, the required parabola curve for the problem under the eccentricity method is over. Thank you and see you in our next video class. Thank you once again.